In this video, we all are going to know about the most complicated topic of physics, the quantum mechanics. Hi friends, I am Subhan and a very big welcome to all of you on your channel Astronomy and Cosmology. So without wasting the time, let's get started. There are two conditions which you have to follow before starting this topic. If you will not follow this, then you will be unable to understand the video. Okay, so the first condition is the science. Whatever you have studied till now will not work here in the quantum mechanics. And the second thing is logic. Logic will not work here. There is no place for logic in the quantum mechanics. Classical physics was not enough to explain all the functions of the universe. That's why we need a new theory to explain. So there were two defaults of the classical physics. First, that the classical physics was unable to explain the phenomena, the laws, or even there was no equation to explain the function of the higher velocity. I mean to say, with a higher velocity, if an object is moving at a very high velocity as compared to the speed of light, I can say that a 10% of speed of light, 20% of speed of light, 50%, even 95% of speed of light. So I just mean to say to all of you that if an object travels at a very high speed, about the speed of light, so at this condition there was no equation, there was no law to describe them because the laws changes with the speed. So we needed a new theory. Okay, and there was second condition where we talks about the very quantum level particles. I mean to say about the subatomic particles of the atoms, like the electrons, protons, neutrons, fermions, bosons, okay, nucleons, quarks, strings. Okay, so at this instant of time we needed a good theory, we needed a new theory to explain these two conditions. So the first condition, the higher velocity condition, was corrected by the Albert Einstein by his theory, the general relativity and special relativity. Okay, and the quantum level particles theory was later formulated by the quantum mechanics. The quantum mechanics theory describe all the quantum level particles, their energy and the quanta. So the modern physics is based on two pillars. First is the theory of relativity and second is the quantum mechanics. And in this video we all are going to know about the quantum mechanics. I have made a dedicated video on the theory of relativity, so you can watch it. I will mention the link in the description. There are a lot of things to know in the quantum mechanics. So if you will understand the quantum mechanics, then it will blow your mind. Quantum theory, or I can say it as a quantum mechanics, is a theory based on the quantum level particles only. It describes the behavior, it describes the energy interaction of the particles at the quantum level, and it also describes that time doesn't really exist. According to the quantum theory, time is only a human made object, it's not a physical object. But if we notice about the Albert Einstein's theory, so he described what he did actually, he described the time as a physical object. So it's creating a paradox between the Einstein theory and quantum mechanics theory. It depends upon you that what you believe. Personally, I don't believe in this theory of the quantum mechanics. I am not saying that the quantum mechanics, I don't believe in the quantum mechanics, but I believe, but this theory, I don't believe in this. Okay, this theory is quite different from it. I believe in Einstein's theory that the time is the fourth dimension, it's a physical object. Okay. The basic structure of the quantum mechanics was formed when Max Planck published his research paper in front of the world about the black body radiation. What he did actually, he described the black body radiation. Actually, the black body radiation is a body, it can be any body, which emits and absorbs a large amount of radiation. Okay, later the Albert Einstein also used this equation and this theory to prove the photoelectric effect. Okay, and later in 1913 Niels Bohr published the model of atom. Okay, so he also used this equation and this theory, so which proved, and it was the starting of the quantum mechanics, and later it became a very popular concept among the physicists, and now a lot of people knows about it. Let's understand a very interesting thing about the quantum mechanics, the state of superposition. So what is it actually? It describes that a atom, not atom actually, it's a particle. So the quantum level particles exist in their all possible states until there is observer to observe them. It means that before an observer comes to it, the atoms or even the particles exist but in their all possible states. Okay, So to understand this concept easier, I am taking the example of Schrodinger cat experiment. So Schrodinger did an experiment in which he put a cat inside a normal metal box, and he also put a small box which was hanged on the wall of the box. Okay, so this box was filled with the radioactive material, and there was a 50% chance that the material would leak or not. Okay, and there was a radioactive sensor which was put near a radioactive material. So if the radioactive material will leak from the box, then it will reach to the radioactive sensor, and the radioactive sensor was attached to the hammer. So if the radio material will leak and it will attached to the radioactive sensor, then the radioactive sensor will cut the rope and the hammer will fall to the jar, and the jar contained very toxic substance. So if the toxic substance will release, then the cat will die. It's an obvious thing. But it depends on the radioactive material, that if it will leak, then only the cat will die. So from that experiment, the Schrodinger described that the cat is died and alive both at the same condition. So this condition where the cat is alive and died at the same instant of time, this is known as a superposition. Okay, so when we will open the box, we will know that whether the cat is alive or dead. But our observation will not affect the life of the cat in our ordinary life. Okay, but in the quantum mechanics, if we would do this experiment with the quantum particles, the result may affect, okay, and you will get the different result. So what will happen if that experiment was done with the quantum level particles? So if this experiment was done with the quantum level particles like the electrons or protons, so the cat may live or die. So the life of the cat was dependent on your observation. Your observation may get the life to the cat, or may this cat will die. So in an ordinary life, this experiment will not make any sense to you, but in the quantum mechanics, this experiment is very useful for the physicists, from which they describe a lot of things from this experiment. So this was a very popular experiment done by the Schrodinger. Schrodinger also told that the repetition of this experiment would also affect the result. For example, if I am doing this experiment at one time, I may get the cat as alive, or if I will do this experiment again, it may be possible that the cat would die or alive. So this makes the multiverse concept, yeah, the time travel, the multiverse are the very interesting concepts which were originated from the quantum mechanics. Okay, so the multiverse is the concept. I have told you about the multiverse in my previous videos a lot of time. So the multiverse, actually, how did the multiverse evaluated? Okay, so the reason is very simple. This cat experiment also made one more universe, where if for example, if I am doing this experiment on the earth and I get the result as a cat as alive, so it may be possible in another universe, if I open this, I may get the cat as died. Okay, so this is the reason why the universe expands, because there are a lot of possibilities of the existence of anything. For example, if I threw dice and I get number 6, for example, so there are 6 probabilities that I may get 1, 2, 3, 4, 5 and 6. Okay, so in this universe, if I do it, I may get 6, but in another universe the result may vary. For example, in the multiverse, if I will do this experiment, I may get 4. In another universe, I may get 2, 3 or any number. So this concept is very hypothetical, but what interesting. Quantum mechanics also describes about the teleportation. You have seen the teleportation in a lot of Hollywood movies, or on your cartoon series like the Doraemon. You have seen the teleportation. In many serials or in many TV shows, you have seen the teleportation. But is it real? Yes, of course, in the science it is real. the teleportation may be possible by dematerialization and the rematerialization. Okay, but actually how we get the concept of teleportation from the quantum mechanics? So actually there is a thing which is known as the quantum entanglement, which is very important and which is very crazy thing which you will know from me. Okay, so actually what is the quantum entanglement? It describes that if the two particles are entangled, if they are in interaction, then if I will do one thing with one particle, it will affect another particle also. Even the distance doesn't matter here. If I put one particle at the corner of a galaxy and if I put another particle to the another edge of the galaxy, the entanglement will work simultaneously. Okay, and even the entanglement works at the speed of light, not at the speed of light but more than the speed of light. For example, right now I am having one particle, if I am having a pair of particles, okay, which is entangled. So if I will put one of the particle at the earth and another particle at the Mars, it will also entangle, it will affect. If I will touch this particle and I will make the disturbance in it, then the disturbance will also being done by that particle at the same instant of time. So it breaks the laws of the physics that nothing can travel faster than the speed of light. But in the entanglement, this process is also going on at the speed of light, but even not at the speed of light, the thousands of times faster than the speed of light. So for example, if I am having the multiverse in the real life, so if I put one entangled particle at the one universe and another entangled particle at another universe, so this property will also work at this such type of condition also. We also know that what is the distance between the two universes? It may be more than trillions of light years or zillions, centrillions of light years. But even this process will happen there. So we don't know. Our physics can't explain that why this happens, but actually it happens. We have seen the quantum entanglement in many experiments, and this quantum entanglement gives the birth to the teleportation. Okay, let's understand one more amazing thing about the quantum mechanics, and that is the particle duality. We all know that what is light. So if I ask you that what is light, what will be your answer? You could have two answers. The one is that light is a particle, or another one is that the light is a wave. But in the quantum mechanics, the light is both a particle and a wave, because at some experiment it acts like a wave, and in some experiment the light acts as a particle, because we all know that the light is made up of the photons and the flow of photons is the wave. Okay, so there was a very famous experiment done by the physicist, and that experiment is popularly known as the double slit experiment, in which there was a light beam and the light was passed through two barriers, and there was a space between the barriers. And at this experiment, what actually happened, the light travels through the barriers and they forms the corresponding patterns to each other, and as a result we get a lot of patches on the screen. But the same experiment was done by the second time, but we get the different result because we put a sensor just behind to the barriers. So when the light was passed through the same source, the sensor just got the photons and the sensor observed the photons, and then the light behaved as a particle. We got the two stripes, okay, at the screen. So you can see this right now. So the same experiment was done by the observer and not observer, so the results were different. It proves that our observation affects the result. So this was a very great experiment. At the first experiment we got the result as the light waves. Okay, we got the light waves just because the light waves were just like water waves. So just imagine if there was a water instead of the light, then the water will also give the same result. It will also form a lot of patches, a lot of strips in the screen, and the same thing was done by the light. So it proves that the light is a wave. But in the second experiment, we got the proof that the light is a particle, not a wave. So which one is correct? Just use your logic. Which one is correct? But as I already told you at the starting of the video, there is no logic for quantum mechanics. The two things which are just opposite to each other may be right. And it's happening here. The light is both a particle and a wave. Okay? The quantum mechanics has predicted the end of the universe, and these theories are very interesting and it will amaze you. So the first theory is the big freeze theory. We all know that the universe is expanding throughout the year. We all know about it, that the universe is expanding since the Big Bang happened. From the Big Bang, the universe is continuously expanding, and the expansion of the universe will never end. It will expand forever. Okay, so the one time will come when the temperature of the universe will become absolute 0 degrees Celsius, or even minus billions of degrees Celsius also. So if we look at the history of the universe, we will observe that at the starting of the universe, the temperature of the universe was more than trillions of degrees Celsius. And with respect to time, the universe started to cool down, and right now we are having a moderate temperature, but in the future the universe will have a very decreasement in temperature, we will notice. Okay, so this may lead to the end of the universe, because no organism will survive at that time and the universe will freeze. The another theory is the big crunch theory, which is popularly known as the big bounce theory also. So which describe big bounce, or we can say it as a bouncing cycle theory also. So which describes that the universe is expanding from the energy of the universe, of the Big Bang. The Big Bang was created from the very high amount of energy, and due to that energy the universe is expanding. And when this energy will end, when this energy will convert into the mass completely, then the universe will start to contract, and there will be a new Big Bang, which will be known as the Big Crunch. So the last theory is the Big Rip theory, which describes that the universe will expand forever. So there will be no end of the expansion of the universe. So one time will come in the future when the atoms of the universe will start to go apart from each other. So this expansion will lead to and the atoms will also break down into 3 subatomic particles, electrons, protons and neutrons. So the atom stability will also break down, and due to this the universe will end. Okay, so the last thing which I want to tell you about this quantum mechanics is the Heisenberg uncertainty principle. So if I ask you a question, that is the universe certain or not, or is it uncertain, what will be your answer? Just give me in the description, in the comment box. Okay, so according to the Heisenberg, whatever is happening in this universe is uncertain. No one knows that what will happen to you in next few moments. Okay, so actually what was happening there in that time when the quantum mechanics was newly born, there were two parties of the scientists. One party think that all the things in the universe is happening at a certain period by the certain calculations of the science, mathematics and physics, and the another party the thought of the another party was that everything is uncertain. No one knows except the God, because the God created the universe, we all know, and he knows that what will happen to you. And personally, I believe in the Heisenberg uncertainty principles, which explain that the God created the universe and we are not having any control. Okay, can you control yourself? No. Do you know that what will happen to you in the next moments? We don't know. So the Heisenberg explained that the net energy of the universe can never be zero, and he explained that the position of a particle can never be at the same place. It means that we can't calculate that the particle exists at this place or it exists at this place. So there is not a perfect calculation. So you can't calculate that where the particle will have its place from after some time. So if you will use any calculation, but even you can't calculate that what will be the position of the particle in the next few moments, because actually it's happening that if you can calculate the position of the electron in an atom, because we know that the mass of the electron is just negligible as compared to the mass of the all atom. Okay, so if you will start to count that, will you able to count? You can't count that after 1 year what will be the place of the uh, atom, I mean to say the electron. So the everything in the universe is uncertain. We are not having any control. You can't predict that it will happen. Yeah, there are some things where the certainty works, but not in each and everything. For example, if we can calculate, we have calculated actually, we have calculated that the rotation speed of the earth and the revolution speed of the earth, so we can predict that after 2 or 3 years what will be the position of earth. But this concept don't works on each and everything. Okay, so this was the Heisenberg uncertainty principle, and it is very important in the quantum mechanics that no one knows what will happen to you next, what will happen to that particle. So actually this was a very difficult concept among all of you. Actually, if you will Google it, then you will also find that the quantum mechanics is ranking at the first place as among all the difficult subject. It is on the first place. I have tried to explain you, it's as easy I can explain you. So we will meet in a new video regarding to a new topic of